Welcome to this video. In this video, you will learn about one of the important name reaction, that is the Diels Alder reaction. Let us see the outline of this video. Firstly, we discuss the introduction about the Diels Alder reaction. Then we discuss the statement and general reaction. Then we discuss the what is meant by dienophile and diene. Then we study about the stereochemistry involved in the Diels Alder reaction. Then we discuss the mechanism and synthetic applications of Diels Alder reaction. Let us see the introduction. Otto von Hermann Diels. He was a German chemist, while Alder was born in the industrial area of the Poland. In 1950, Nobel Prize in Chemistry, which was awarded to the Alder, shared with his teacher Diels for their work. Now this work is known as the Diels Alder reaction. It is the one of the very important uh, organic reaction which is known by the scientist named as the Diels and Alder. For his work, both scientists got the 1915 Nobel Prize in Chemistry. Let us see the statement of this reaction. Okay, the reaction between the conjugated diene and alkene to produce a cyclohexane compound. This reaction is known as the Diels Alder reaction. It is the addition type of the reaction. Okay, the first reactant is the conjugated diene and another reactant is the alkene. On addition, it forms the cyclohexane. This reaction it is initiated by the heat, that's why we call as the thermal reaction, or it may catalyze by using the Lewis acid. Okay, this reaction we carried out by with the use of solvent or without the use of the solvent. Okay, the simplest example is this is the 1,3-butadiene CH2 double bond CH single bond CH double bond CH2. It on treatment with the ethene CH2 double bond CH2 at 473 Kelvin. This on cycloaddition they form the cyclohexane. Let us see the another example, that is the 1,3-butadiene. It on treatment with the ethane at 473 Kelvin we get the 1,4-cyclohexadiene. In the both cases we get the 6-membered ring as the product. Okay, in this reaction there are two reactants. One is the diene component and another is the alkene component or alkyne component. This alkene or alkyne component it is also known as the dienophile. Phile means to attract. It attracts towards the diene. That's why this component is known as the dienophile. Okay, this reaction is also known as the 4 plus 2 cycloaddition reaction because this diene component it contributes the 4 pi electron while the dienophile it contributes the 2 pi electron. That's why it is known as the 4 plus 2 cycloaddition reaction. Okay, another it is also known as the 1,4 cycloaddition because the conjugated diene this is the carbon number 1, 2, 3 and 4. Carbon number 1 and 4 are added towards the dienophile. That's why it is also known as the 1,4 cycloaddition. Okay, then next is the let us see the reactant involved in the Diels Alder reaction. The that is the dienophile. It is the alkene component of the Diels Alder reaction. It always contributes the 2 pi electron in the reaction. It may be the simple, that is the ethene, or it may be the substituted, it may be the mono substituted or disubstituted, it may be the alkyne, that is the having carbon carbon triple bond, it may be the cyclic like this one, or it may be the substituted acyclic, it may be the alene, or it may be the benzene. If the reaction, if we want carried out at normal temperature condition, then dienophile, if it carries the electron withdrawing group, the substitution XY may be the carbonyl group, aldehyde, ester, cyano or nitro group. These are the electron withdrawing groups. If attached to the dienophile, then it favors the reaction at low temperature. The second component of the Diels Alder reaction is the diene. It must be a conjugated diene. As we know, diene means it having the two carbon-carbon double bond. Diene, it is of the three types, that is the isolated diene in which double bonds separated by the more than the two single bond. Second is the conjugated diene in which the two double bond are separated by the one single bond, or if double bond single bond are alternate, that is called as the conjugated diene. And third type is the cumulated diene in which the double bond are in the succession. In the Diels Alder reaction, diene it must be the conjugated diene, means the double bond are separate, must be the separated by the only one single bond. It is the electron rich center for the dienophile. This conjugated diene, it always contributes the 4 pi electrons in the Diels Alder reaction. It may be the acyclic, heterocyclic or aromatic. This is the simple 1,3-butadiene. It is the substituted 1,3-butadiene. These are the acyclic. It is the cyclic, that is the cyclopentadiene. It is also cyclic. It is partially cyclic in which the one double bond it is in the ring while the uh, another double bond it is the outside the ring. It may be the heterocycle or it may be the aromatic. This compound can act as the diene in the Diels Alder reaction. If the substituted diene, they carries the electron releasing substituent, that is the electron donating group, undergoes the easy reaction. Okay. The most important condition for diene is the it must be capable of exist in the cis form. Then it undergoes the Diels Alder reaction. This is the trans form of the Diels 1,3-butadiene in which one double bond and another double bond it is the opposite side of the single bond. This trans form unable to do the Diels Alder reaction. Then this trans 1,3-butadiene it requires about the 5 kilocalories of energy. It goes converted into the cis form and then this cis form undergoes the Diels Alder reaction. Because of this reaction, the Diels Alder reaction, the conjugated diene, it must be in the cis form. In the cyclic diene, of course, they are both the double bond they are on the same side of the single bond. That is, it naturally exists in the cis form. Okay, because of this, the cyclic diene react more readily than the acyclic diene. Because in the cyclic diene, they are in the cis form, while in the acyclic diene, they exist in the trans form. They must be converted into the cis form. That's why they undergo then and then only it undergoes the Diels Alder reaction. Okay, this is about the diene. Then about the stereochemistry. When both dienes and dienophiles are symmetrical, then there is the possibility of the formation of the two product. Suppose the substitution at the carbon number 1 and dienophile also substituted. The reaction in this the product it is formed by the this double bond goes here, it forms here double bond, and this double bond goes here, it forms the single bond between these two carbon, this new bond, and this double bond breaks and form the single bond between these two carbon. There is the formation of the this product. It is the 1,2 substitutive product. The another possibility is that the CHO group it may be the this side. On rotation 180 degree, the CHO group goes here and there is the formation of the 1,3 substituted product. This 1,2 product it is also known as the ortho product and this 1,3 it is also known as the meta product. In this case, there is the formation of the 1,2 product, that is the R2 product, in the major quantity, while the 1,3 that is meta product they are in the minor quantity. Okay. Let us see the another example in the conjugated diene. In this conjugated diene, there is the substitution at the carbon number 2 and dienophile also substituted. There is the possibility of the formation of the two product, that is the 1,4 product, that is the para product, and the 1,3 product, that is the meta product. In this case, there is the formation of the 1,4, that is the para product, it is in the major quantity, while the 1,3 that is the meta product, it is in the minor quantity. Then we can say that when both dienes and dienophiles are unsymmetrical, there is the formation of the two products in which there is the 1,2 ortho or 1,4 that is the para, they are in the major quantity, while in the both the cases the 1,3 product, that is the meta product, they are in the minor quantity. Okay, then about the stereochemistry, the Diels Alder reaction, the stereochemistry of the substituent in the starting material is retained in the product. That is, if the dienophile, that is the groups they are in the cis in the dienophile, in the product the group will be the in the cis form. Vice versa, the groups that are in the trans in the dienophile will be the trans in the product. That is the stereochemistry of the reactant or the substituent in the starting material is retained in the product. Let us see the mechanism of the Diels Alder reaction. Diels Alder reaction, it is the pericyclic reaction. This is the one of the type of the chemical reaction. Pericyclic reaction means they occur in a single step, and it single step by the concerted mechanism. Then what is meant by the concerted mechanism? In the concerted mechanism, it involves the simultaneous breaking and making of the bond by cyclic redistribution of the bonding electron. It means there is the breaking of some bond and making of the some bond simultaneously, and there is the redistribution of the bonding electron. In the Diels Alder reaction, there is the formation of the six-membered transition state. The example, the mechanism is goes like this one. Okay, this double bond in the conjugated diene goes here. It forms the double bond here. This double bond break and forms the single bond between this carbon and the dienophile. This double bond break and it forms the bond between this carbon and this carbon. There is the formation of the this single bond. In this case, in the transition state, there is the simultaneous breaking and making of the some bond, and there is the cyclic redistribution of this bonding electron, and there is the formation of this transition state which gives further the product, that is the cyclohexane. Let us see the synthetic applications of the Diels Alder reaction. This Diels Alder reaction, it is used in the synthesis of the quinone and the polynuclear hydrocarbon. 1,3-butadiene, that is the CH2 double bond CH single bond CH double bond CH2, react with the 1,4-benzoquinone. This is the 1,4-benzoquinone. It forms the 5,6,9,10 tetrahydro 1,4-naphthoquinone. This is the first synthetic application. The product form double bond goes here, it forms here double bond. This double bond break, it forms the single bond between these two carbon. This double bond goes here and it forms the single bond between these two carbon. There is the formation of the this naphthoquinone. The second important synthetic applications is the it is used in the synthesis of the alpha terpenol. Okay, isoprene, that is the CH2 double bond C CH3 single bond CH double bond CH2. It reacts with the methyl vinyl ketone, that is the CH2 double bond CH single bond CO CH3 in presence of the hydroquinone. It on Diels Alder reaction, it forms the cyclohexene derivative. This intermediate it is used in the synthesis of the alpha terpenol. It on again treatment with the methyl magnesium halides, that is the Grignard reagent, followed by hydrolysis we get the alpha terpenol. The third synthetic application is the it is used in the synthesis of the compound. One compound it is prepared by using this Diels Alder reaction, that is the cyclopentadiene. It reacts with the vinyl aldehyde. It forms this intermediate. This intermediate on sequence of the reaction we get the campane. Then last synthetic application is the it is used in the synthesis of the catridine. Furan react with the acetylene dicarboxylate. Sorry, this is the triple bond. It forms this intermediate which is used in the synthesis of the catridine. Okay, thank you.